So let's do something a lot more complicated with that superhero social network data. What we're going to do is find the degrees of separation between any two superheroes. And to do that, we're going to introduce a concept called breadth first search, which is a computer science algorithm, and illustrate how you can use Apache Spark to implement what might not seem at first to be something that lends itself to distributed processing. But through some creative thinking, you can take even complex algorithms like this and make a Spark application out of them. So maybe you've heard the story that the actor Kevin Bacon is 6 degrees away from any other actor in Hollywood. That is, if you look at the people that Kevin Bacon has appeared with in other films and the people that those people appeared with in other films and so on and so forth, everyone's within 6 degrees of Kevin Bacon. And I can tell you, having worked at imdb.com, that's actually not true. The number is much smaller than 6. People are really, really well connected, more so than you might think. The same is true of the superheroes in our superhero social network. You might be surprised at just how closely everyone's connected to, say, Superman. And to get a little feeling of what I mean by degrees of separation, let's take a look at this sample social network here again. So in this example, the Hulk and Spider-Man are 1 degrees of separation apart from each other because they have a direct connection. But for example, Iron Man is 2 degrees of separation from Spider-Man because we have to go through the Hulk to find Iron Man. So for example, to make it more concrete even, the Hulk and Spider-Man may have appeared in the same comic book, but let's say that Spider-Man and Iron Man never did. But Iron Man and the Hulk did, therefore they're 2 degrees of separation apart. Now take Thor, for example. If we take this path, we might say that he's 3 degrees of separation, but we always talk about the shortest path. So in the case of Thor, he would be 2 degrees of separation because they are connected by one person, the Hulk. Okay, 2 steps to get to Thor. So how do we do that? Well, we need to use a search algorithm called breadth first search. So what we have here is basically a network, a graph in computer science terms. So imagine every one of these circles represents a superhero in our social graph. And these lines represent the connections between them, the people that appear together in the same comic books in this example. So let's pretend this is what a social graph or a piece of the social graph looks like in our social hero super network. It illustrates different superheroes as circles. The lines represent connections between the superheroes. And the number in the middle, in this case infinity, represents the distance from any given superhero that we start with. So let's say, for example, we want to start with superhero S. Maybe that represents Spider-Man. What we want to end up with is a graph that indicates how many degrees separated from Spider-Man, from node S, is every other node in this graph. So to do that, we need some sort of approach, some strategy. So let's start off with a couple of basic ideas here. First of all, we're going to come up with the idea of maintaining the state of a given node, and it can be one of 3 colors. Now, white means that a node is completely unexplored by our algorithm, so we're starting off with everything being white as our initial state because nothing has been explored yet. Now we have other colors, gray meaning that it needs to be explored, and black meaning that it has been fully explored. Okay, so the color represents the state of each superhero as we search through this graph. White means it hasn't been touched at all, gray means it needs to be touched, and black means we're done with it. And inside each one, we're going to keep track of the degrees of separation from some given character that we started with. Okay, that's pretty much all there is to it. So let's see how that works. So again, our initial state, we're going to start off saying we want to measure everyone's degrees of separation to this node, node S. Maybe it's Spider-Man, who knows. So to do that, we're going to color this first node gray, meaning that it needs to be explored, and the initial degrees of separation will be 0, because Spider-Man is 0 degrees away from Spider-Man, because Spider-Man is Spider-Man. Makes sense so far? So what that gray indicates is that we need to explore all the connections of this node, so we'll do that next. So by reaching out on the tendrils of that gray node, we're going to color these new connections gray, meaning that I need to connect to explore them as well. And in the process, I'm going to increment the degree count from 0 to 1 and store that in this new exploration here. So we've increased 0 to 1, and we've propagated that out to all the connections of the original node. Now we've colored that original node black, meaning that we're done with it now. We've already explored its connections, and now these 2 nodes are gray, meaning that they need to be explored further. Now if we had a situation where there was already a number in one of these connections, we would maintain the lowest connection count, kind of like we showed before with the Hulk and or Spider-Man and Thor, for example, being connected through the Hulk. So we always maintain the shortest distance that we find, okay, and the darkest color. So if we then go off to split out this node that was gray, we are now going from 1 to 2 in our depth. And we will go out to its connections, make them a 2 because we're incrementing that, and color them gray. We need to do the same for this connection over here. And that gets explored out, and a 2 goes there. And now that we're done with these two nodes, they get colored black, so we know we're done with them. So that's another iteration of the BFS algorithm. Basically, we keep iterating through this process of exploring connections, coloring them gray, incrementing the degree of separation count, and then marking the node black that we actually processed. And we just do this over and over and over again until we're done. So this is another iteration done now. Now these all need to be explored, all 3 of these nodes. So we'll see how that works here. These get branched out, and we propagate out the next level of 3 out to there. This guy doesn't have any connection, so he's just going to turn black. We're done with that branch. And finally, we'll explore any unexplored connections of these guys. There aren't any, so they end up going black as well. And that is our final graph for degrees of separation from node S. So the way to interpret this, if you look at any given node, it already has the answer in there of how many degrees of separation am I from S. And you can see we are 1 degree from between S and W, but from T to W, for example, it is 2. And again, we preserve the shortest value there. You could actually do it through 3 hops if you really wanted to, but 2 is the shortest path. And that's what breadth first search does. That's how it works. That's actually a pretty fancy pants computer science algorithm that they ask you on job interviews at big fancy computer sciencey companies, right? So you now understand breadth first search. Congratulations. Not that complicated. So how do we translate that into a Spark problem? Well, that's the challenge, right? But for now, it's important that you understand the algorithm. So if you need to go back and rewatch what we've done so far, please go back and do so, and we'll move on with implementing this in Spark in our next lecture.